Hello, Keith Rucker at VintageMachinery.org. Well, if you watch my channel regularly, you saw about a week or so ago, we finished up the second Richard King hand scraping and machine rebuilding class that was taught here at my shop. We had about 10 or 12 people in for a week learning about hand scraping and machine rebuilding. I'd taken the class previously. I'd been, working on my scraping techniques, but what I really wanted to concentrate on was working on this lathe, actually doing some rebuilding. And I wanted to take advantage of having Richard King here during the week to kind of help me learn about how to properly do measurements on this machine, to figure out where, and come up with an appropriate game plan on how to proceed. So I didn't really do a whole lot of scraping in the class per se. I really spent more time working on really this machine. And it was also helpful that Lance Balsey, who was another second time classmate who was here, he took the class back in the winter when I took it the first time. He was here as well, and he was actually working on his Monarch 10EE, where he sent his bed out and had it reground, and he was scraping the saddle and all that kind of stuff in while he was here. So it was really nice because his machine is very similar to mine, just on a little bit smaller scale. Same basic construction and stuff, both on being Monarchs. And I was kind of able to watch what he's doing because he was a little bit ahead of me. He had his bed was already done, already had turkite in his saddle, and he was just basically getting it tuned in. So I was watching him real close throughout the week and also kind of getting mine up to speed. So just a little bit about this machine here, or a little bit about what you're about to see. So we started out with just getting some good measurements on the ways themselves, so that we really kind of knew what condition this machine was in and where our starting point is. And I shot a little bit of video, and we'll kind of put that in for you to see here. So on this machine, before I did anything else, the first thing I want to do was to get the bed fairly level, as level as I could. And it's actually pretty level right now. And we've talked about leveling machines before and the importance of that. And the term leveling is somewhat of a misnomer. You're really not, the machine does not have to be perfectly level in all directions. What we're trying to do more than anything else is to take the twist out of the bed. So I want the bed, as far as on the level, to read the same on this end as I do on the other. Now, if it's actually a little bit one way or the other, that's not important. What's important is it's exactly the same. Now, as far as the tilt going up and down, you want it to be fairly level. On this machine, I actually purposely have the back end of the machine up a little bit higher than the front end. And the reason is because there's a sump down the bottom of this machine for coolant, and the drain is right over here. So what you really want to do is you want to have the back end up so the water or the coolant runs down to this end. And even ideally, you may even want to tilt it back. I'm not talking much, but just tilt the whole bed back just a little bit so that it's running toward the back there, but have it same on both ends. So to do this, I started out, I built a little jig here. This is just made with some 1, 2, 3 blocks. I got a piece of all thread in there. And, I'm running on the 2 flats on here right now. And, I start up here close to the headstock. There's not a lot of wear in the bed on this end or on the other end because there's the carriage, and particularly on these 2 ways, there's just not a lot of wear in those ends. So I'm working on maybe not perfectly virgin surfaces, but they're pretty good. And I started with my regular Starrett number 98 machinist level, and this level is accurate to I think 5/1000ths of an inch per foot. I got it level, and once I got it level with the Starrett number 98, I went to my Starrett Master Precision level, which is level accurate to a 1/2,000th per foot. So that level here is much more accurate. And I dialed in using my leveling feet on the end down here. We dialed it until we got this dead on level. And then I went to the other end of the machine, again down on the end where there's very little wear on those ways, because you just don't travel to that end of the machine very much. We did the same thing, and I leveled the other end. I went back and forth until we got both sides reading the same thing on the level. And the nice thing about this little rig that I built right here is that I've got it set up where I've got a little block in the back. The back side back here is machined flat and square, and that's also a surface that doesn't really see a lot of wear. So that's a good datum to work off of. I can do measuring off of this back side, and that's what I'm going to do here next, is actually measure these ways off of this datum in the back. But right now I'm looking to see how much wear is in here, and I can just slide this level down to various spots, and I can now look on my bubble and see where it's at. Now let me zoom you in here. I want you to see what I'm looking at. All right, so I'm looking here, and this is fairly level, and it's not, basically my bubble is right on the back edge back there on this line, and the angle, I don't know if you can even see it in the screen, but the angle you're looking at may not look, I can look straight down on it. But if you look right here in the ways, you can actually see some wear marks right here. And the carriage, when it goes back and forth, it actually rubs right here. And you've got some pretty nasty looking wear marks in there. You get down a little bit farther and you don't see those, but this is where most of the wear in the machine is going to take place, because this is where most of the work on that saddle's at. What I'm going to do is I'm going to slide this down and kind of get over this wear, and you see the bubble is starting to drop off. So it's moved right there, it's moved one line in there. Now my level is accurate to 0.0005 inches per foot, so a half a thousandth per foot, or 5/10,000ths of an inch per foot. Now between these two, this is about 9 inches between what we're measuring, so we're not really measuring a whole foot, so you have to take that into consideration. So really it's about 2/3 of a foot that I'm measuring. So if you do the math, that actually comes out, each line in this case is measuring 3 1/3 tenths. So right here the saddle has dropped down by about a little over 3 tenths. We can slide down a little bit more, and you can see that bubble moving some more. Right there, it's moved about 3 lines. So that's 3, 6, 9, that's 1/1000th low right there for all intent purposes. And we move it on down some more. And it's down a little bit more. I'm estimating now. I've done this throughout the length of the machine, and I'm not going to show you every bit of it, but right in here, there's a little belly in here that it drops down a little over 2/1000ths. So we got a 2/1000ths dip, at least in this one way, right here. Now once you get just past this, it starts going back up to 0, and by the time you get to the end of the machine, it's back up to the 0 mark. So anyway, this is just a way that we can start to look and see what kind of wear we've got in here. My next step is we're going to put an indicator on here, and we're going to actually measure on both sides of this way. And again, I'm working off of a area back here that should not have seen wear. It's a good datum to work off of, and we can start to measure with an indicator how much wear is in this way. And I'll bring you back and show you some of that in a little bit. All right, so update on my Monarch here. I've been doing some more measuring, and just using the same little jig here that I built. And what I'm measuring right now is the any wear in this way on the front. So specifically what I'm measuring is how much wear in this direction, not down, but how much from side to side. And I've gone through here, and basically I got on the back and moved the indicator, holding it nice and steady. I had another classmate come in here and write down the measurements just on the ways. And surprisingly, it's not as bad as I thought it was going to be. So we start out at 0. It's about 1/1000th in here, about 1/1000.5, back to 1/1000th, 1/1000th. Again, this is where most of the wear is. 0, 0, 1/1000, 1/1000. So once you get down here, it's actually out a little bit, or from down here. But this area has wear. This +1 on the end is probably more original finish. But bottom line is I've only got about 1/1000.5 at the worst right here. in this direction, which, while it's not perfect, it's really not terrible either. So next thing I'm going to do is come in here and we're going to measure this side of this way. And this side theoretically should be the side really that has most of the wear in it because of the tool pressure as you're pushing is pushing on this way. So I'm going to set up and we're going to come in here and measure this one. All right, so back over here on my Monarch lathe, I've got my little jig here set up. I got my indicator coming down on the back side of this way. We did the exact same thing. We came in here and basically just mapped this thing out all the way up and down to kind of see. I just took a Sharpie pen and wrote on here. You know, we started with 0 right here, which I know there's wear down here, but that's just kind of where I'm starting at. There's -1, this is thousandths, -1,000, -1, 1, back to 0. Then it goes +2, +3, and pretty much +3 the rest of the way down the bed. So in reality, down here, this is the area that has seen little to no wear. So in reality, this is 0, my +3s. So if you go through here and you kind of look at it, we've got about 4 thousandths wear on the back side of this this way. So again, not perfect, but it's not absolutely terrible either. So after doing all the measurements, and you know, we've already talked about that a little bit, but at the end of the day, I consulted with Richard, you know, what do we do about the bed on this machine? I had 2 options. Scraping it was not really a very good option because these are hardened ways, just really can't do that very effectively. So I could either take the headstock off, get down to just this casting, send it off, have everything reground down to, you know, precision, factory new condition, or I could just live with what I got. And the cost of getting this machined or reground, I haven't gotten any quotes. I'm estimating it probably would cost between $5,000 and $10,000, just depending on who it went to, whether shipping was involved, and et cetera, et cetera. A lot of money, and quite honestly, once I got this machine completely restored, you know, I probably couldn't even get my money out of it. I would have known it had been dead nuts right, but it really just, this machine would not have demanded that even in a rebuilt stage. So while there is wear in here, in the grand scheme of things, it's relatively minimal. You know, we're talking about probably 3 thousandths total wear in the worst part of the bed, which is kind of right here where most of the work happens. And 3 thousandths wear, 3 thousandths kind of downward wear in here does not necessarily mean when you're turning something, it's going to be 3 thousandths out. It's more to do with alignment. You know, as your tool is going, if it drops or raises 3 thousandths of an inch, but it's running parallel, it's not going to affect the diameter of what you're turning that much. It will affect it to a small extent. But after talking with Richard, we just said, you know what, we're going to live with what we got. And quite honestly, I've worked on machines that have a lot more wear than this in them, this machine in it, and I've done very good work on those lathes. So anyway, we decided to stick with it. So the next step, once we determined what the wear was, how much wear, where it was at, et cetera, with mapping this thing out, we went to the saddle that rides on here, and we really started evaluating that and looking at how much wear was on that. And again, we're going to go to some other videos here, and you can kind of see some of the things we did and the game plan. We'll bring you guys up to date on the big Monarch 16-inch lathe. Continuing to work on this under Richard King's guidance, and thank goodness he's here, because I don't know that I've been brave enough to do what I'm about to do this thing without his encouragement and his advice and expertise. But what I've got here, this is the saddle off of my lathe over here, and we've done a lot of measuring over the last couple of days. I've been running around kind of helping with the scraping class at the same time working on my lathe, and it's been kind of slow going, but we've done a lot of measuring, looking at the wear on the machine. I showed you what the ways look like over there, and while they're not perfect, they're not terrible in the grand scheme of things either. And what we decided to do is, okay, let's see if we can work on the saddle.
and take care of the issues. Because those are hardened ways, yes, there is some wear in them, probably about 3/1000 wear in the worst place. But they're hardened. That's not where most of the wear took place. Most of the wear took place in the saddle, because this is a casting. It is not hardened. This is actually where the wear is intended to happen. And there's multiple kinds of wear in here, and I probably can come in here and kind of talk about that. But what we've decided to do is we're going to actually build these surfaces back up with Rulon. And I'll grab a piece of it here. All right, so this is a sheet of Rulon. It's a plastic type material. It looks like it has maybe some like impregnated metal in it, but these are basically for building up wear in machine ways and machine pieces, and it's designed exactly for that purpose. A lot of brand new machines, instead of actually having cast iron ways, they actually use Rulon or Turkite, similar product, for the things to ride on. And what we're going to do is we're going to actually apply this product into the ways on the bottom of the saddle here, and then we will scrape this in to match the lathe. Now, but by adding this material, we're able actually to build this back up. And there was, looking at all the different wear, about the worst place in here is about 20/1000 wear. So this is actually, this material here is, what is it? It's 47/1000 thick. So it's going to go in here, but this is too thick right now. And the reason I've got this set up on the mill is we're actually going to mill some material out of these ways, these wear surfaces in here, so that we can apply this Rulon and not have so much material to have to take back out. So the step I'm going to do here is we're going to actually mill this out, mill this flat, mill this V, and take some material out. Yes, I'm nervous about it, but at the same time, this does not have to be, it needs to be set up, it needs to be done right, but if it's not perfectly flat, we're going to scrape the Rulon in to get it actually fitting the machine itself. So it doesn't have to be perfect, it needs to be pretty darn close though. So let me, I'm going to zoom you in and kind of talk about some of the wear in here and how we did some measuring on that. So when I was looking at wear in here, the first thing I did, and I can't really show it to you now because we've already taken these out, but right along the top here, there was a little ridge on both sides. There's also this one over here. And basically, that's where this way is wider than the way that it's riding on. And over time, as this wore down, it left a little wear ridge on the edge. Now, the bottom of that wear ridge was original material. So we were able to actually come in here with a depth mic, and I was using a smaller one than this, but just kind of show you. And I was able to measure the height of that ridge all the way down through here. One of the key things when you're looking at machine wear is you need to find a surface that you can reference off of. And in that case, that the top of that ridge was original, and then it's down to where it's worn. So we were able to go in here and I mapped things out. I actually wrote measurements on here. The measurements on here is something else right now, but I was able to kind of see, how much wear down was there. And on this way here, it ranged anywhere from, I think on one end it was 8/1000 on the end, the other end it was 10/1000 on the end, and in the middle it was about 4,000 or 5,000. So you kind of get some rocking, so the ends tend to wear a little bit worse. And also the inside wears worse because that's where the pressure from the tool pressure is on the lathe. I also took a dowel pin, dropped it down into this groove. Again, the surfaces here and here, these are unworn surfaces, particularly here. This is where this mounts down on top of the apron. So I was able to come in here again with a depth mic, and I was able to measure down to that dowel pin. And that also gave me some measurements. That's what the measurements on here are, showing how far things had worn down in there. And it basically went, the low was 0, the high was 2.5. And it doesn't show you the total wear. That you get that more from the the 8 thousandths or whatever, and 10 thousandths that I had on this ridge. But what this tells me is how much difference there is in the how much taper there is to this. And so this is the edge that gets the worst wear. This is the front edge of the apron or the saddle, and it basically became zero. And it was about 2.5 thousandths deeper on this end than on this end. And in the process of doing all this, I'm taking notes, I'm mapping it out on a piece of paper, I'm adding all these measurements together, and it kind of tells me how much material I need to take out of here to put the Rulon in to add some material back in. So anyway, that's where we're at now. We've got this set up on the mill. You know, this saddle doesn't really fit the mill. The only place to clamp is in the middle, which is where the cross slide is. That's the high spot. So we've got it clamped here. Had a lot of stuff cantilevered out here on the edges. That was not good. So I took some 3/8" bar. We bolted that down. There's actually set screws on the bottom of this bar coming up and touching all four corners here. So I've basically added support out here beyond the edge of the table to support everything, and hopefully that's going to be a nice firm foundation on here. We swept this back here in the back with an indicator. We've got this lined up. So hopefully here pretty soon we're going to go ahead and mill out some material. I don't remember exactly how much material we calculated we're going to have to take off in different places, but we're going to have to take out, I think, about 20 thousandths off of most of this to put the Rulon in. Well, this morning of day 5, the last day of the scraping class, and I thought I'd give you an update on my lathe here. It's kind of funny, I've been in a scraping class all week and I haven't even done any scraping. I've been doing more machinery building stuff this time around. We set this up on my lathe, or on the milling machine. I kind of had to build a carriage for it to sit on because it was so big. It was bigger than the table. We clamped it down in the center, but it was kind of cantilevered out on the edges where it could tip. So I took some 3/8" rod, or 3/8" bar stock, bolted down the table. We put some screws in the bottom that came up and kind of touched on the four corners to support it. I actually put an indicator on there and pulled the screws up, and when the indicator started showing that it was moving, I knew that my screws were touched, and then I had a lock screw on there and tightened them up. But once we got that done, we milled out the stuff straight up and down.
All right, guys, we're actually milling the apron of the saddle leather on the lathe. We're making our first pass. Basically, just take it off the surface out, take it from flat back here. Got to take 39 thousandths off of it. We're going to take our time and sneak up on this side.
Then I nodded my head over to 45 degrees and I milled out the V in the ways for the ways. So that was, we used the bottom of the mill for part of it, and then we did the side of the mill on the other one. And I did it in two different operations. So I did the bottom first, and then we came in and did the side. So I wasn't cutting on one side at a time. Once that was done, we took the Rulon material. I cut my strips, and I mixed up some 2-part epoxy that's made for this material, and we epoxied that into the bottom. And basically, what you see here beside me, this pile of contraption, is the clamping system. So we actually used the bed of the machine as a form, because this is what it's going to go on to. So I actually put, you can see on here, some saran wrap on the ways to keep any epoxy off, and then we put the turkite on top of that. Put the epoxy, of course, was on both of the part and the ways, or the strips, and with a bunch of people we came over here and basically set it down and kind of got all our strips in there. And then all this weight is just clamping pressure, and we let that epoxy set overnight. This is actually all ready to come off now, and what I have to do is clean everything up, trim up the Rulon because it's, we cut it bigger so that in case it shifted around or whatever, so I have to trim all this stuff up. And hopefully when we get through, I can start scraping the Rulon now to actually fit the bed, the ways on the bed. So anyway, interesting project. This is going to take the wear out of the saddle. It's going to get the saddle back up to the height that it should be, and give us basically a nice level surface to work off of, because there was so much more worn on the front side than on the back, which is what you'd expect, because that's where the pressure is from the turning of the tools, is on the front of the saddle. So anyway, a little update on this. Apologize we didn't have video step by step, but it was just so crowded in the shop with so many people, and also so loud in here that it was really difficult for me to try to set up cameras and get video while we were doing this. People were bumping into cameras and you couldn't hear anything because of the noise level. So anyway, a little quick update. So I got the saddle pulled off of the ways over here where we glued in this Rulon, same material as Turkite, and you can see this these wear strips in here now. So again, this is a Teflon type material, and it's built up now. Again, we machined the ways out to make room for this, taking into consideration the wear, and it's pretty close. It's pretty close. But now what I got to do is come in here and trim all this stuff up. We cut this stuff a little oversized, get all the epoxy off of here. So what you're looking at now, this is basically where we ended up with at the end of the class. And I've still got a lot of work to do to this saddle to get it exactly right. But we've got the Turkite is in here, or in this case Rulon, Turkite Rulon, it's basically the same. By the way, I kept telling you guys this the material, and I've clarified, found out a little bit more about this material. So this is basically a Teflon plastic, and it's impregnated with bronze. And I know a lot of people are saying, man, I wouldn't want to have that on my machine. There's actually been a lot of tests done. This stuff wears better than cast iron does, which is why a lot of newer machines, particularly CNC machines being made today, they come directly from the factory with this Turkite or Rulon in there. And again, the studies have shown that it holds up better over time. And the nice thing about this is when it does wear, instead of having to go in there and machine everything out like I did, you can just pull the old Rulon out, put some new in there, scrape it back in, and you're ready to go. So, not original, but this definitely, I think, an improvement, at least this case. A couple of comments, the amount of material we had to take out of this. We added up the wear over on the bed in the different places. We added up the wear that we were able to measure. In here, I also used a level, just sliding this back and forth and looking at how much tilt difference there was in different places. And, we came in here and calculated, and I wrote in here in different places, how much material needed to be taken out in different places in here to get it back down to original. And of course, there was a different amount of wear on both sides here. We basically took the same amount out, and we took some off the back. And if we did all our math right, this part, when it goes back on the lathe, it should at least be level or fairly close to it. And we can adjust that by scraping in here. I showed you how it looked like when it came right out. We've since trimmed all this stuff up. When you epoxy this Turkite in, you want to purposely leave it a little bit long, because this stuff will creep on you while it's drying. While it's still wet stage, you get the weight on it, and it's just like it wants to slide a little bit. So you leave it a little bit long, and I didn't see where it had done much creeping, but Richard recommends leaving about 1 inch on either side. Anyway, we got all this cleaned up. I did kind of come in here and do some rough scraping in the centers on these two surfaces, which is the way it was originally. The centers here, you really don't want this part touching the ways. You want it to be touching on the ends, because you don't want to have a high spot in the middle and this thing rock. You want it to be touching on the four corners. So we relieved out the middles a little bit just using a hand scraper. I blued up the ways on the lathe, and without any real scraping other than just cleaning it up, we put it on here, and you can actually see the blue in here. So we're kind of touching here and here. So we got
fairly decent contact right through here, right off the bat. Touching a little bit on here, not so much out on the ends. Same thing in here, we're touching here and here. We got a little bit of contact in here. Bottom line is, you know, for no scraping right out of the bat, I've got contact pretty much in all 4 areas. You know, maybe here we need to kind of take a little bit more out here and try to move some of the contact out this end. But that's my next step, is we're going to have to get all this scraped in. Quite honestly, I'm probably going to need to have someone here to help me while I'm doing that. This is just too big of a piece to be picking up and moving around by myself. And with having to flip it over and stuff, while I could use my engine hoist to do it, it's just easier if you have a second person to do it rather than trying to do it that way. So anyway, this is going to be a project for down the road, but we've made good progress on it. Well, there you go, guys. That's kind of where we're at now on the lathe restoration. And this is probably going to be a project I'm going to work on this summer. It's kind of my next machine in the queue. I really want to get this thing going. So I'll have a little bit more capacity when I got on the LeBlond over there. Plus, I really think it's going to be a nice machine when we get done with it. So this will be my summer project more than likely. There are a few other things that I'll just quickly mention that we did. Of course, we took the saddle and the apron and all that off. We took all the screws and lead screws and feed rods and all that off while we were to get everything off. Unfortunately, it was just so hectic in here. I didn't have a camera running, so you guys didn't get to see all that. You'll get to see it all go back together. I also had a broken piece down here on the feed lever, and I've got all that apart. I'll show you guys that in a later video, and I'm gonna have to do some repair work there. The good news is I think it's repairable. So anyway, we'll cover that down the road when I get to that point. The next thing I really want to do is I want to pull the top off of this and do a good visual inspection of the gears. I have kind of, you know, just turning the headstock and watching the gears run. I don't hear anything that causes me any concern, but I really want to lay eyes in here. I've taken the bolts out of the top, and whoever this machine's been into before, and whenever they put this back on before, they used a silicone as a gasket material in here. And this thing is stuck. I mean, it is just absolutely glued together right now. So I'm gonna have to figure out a way to break that silicone in there and get this thing taken apart. I'm a little bit aggravated with it, to be honest with you. I'm gonna have to figure out the best way of doing that. I don't know how I'm gonna do it. I was hoping I could just put a couple of screws in here and take my engine hoist and just pick up on it and break it that way, but there's no way to do that without drilling and tapping some holes in here, which I really don't want to do. And I don't know, I may try to see if I can put a little heat on it or something and get it loosened up that way. But like I said, I really want to just get my eyes in there and check it out. But with that, that's going to be a wrap for right now, and we'll be doing more work on this machine throughout the summer, like I've previously said. I've got a few other projects that I really need to get wrapped up, and I've actually started on a few other things. We got to get the lead screw for that lathe that I'm working on, and it seems like every time I get started on that, I run into another little snag, and I need another little tool or need to do another step before we get done. But that's really at the top of my list right now to get that finished up. And there are a few other little jobs in here I need to get knocked out. We'll have some videos on those as they come in as well. But hopefully we'll have this beast running soon. Maybe at least by the end of the summer. With that, thanks for watching, guys, and stay tuned. We'll be bringing you more on the Monarch 16-inch lathe restoration as it goes.